This is our October 17th, 2024 meeting of Chapter 37, the Washington, D.C. chapter.
I am going to propose that we give the reins over to Chuck and let Chuck start his presentation.
Tonight we'll look at Burk's remote control systems and architecture, and that architecture is based on distributed intelligence with centralized control. So these are the two primary remote controls in the product line. The one on the bottom is the Arc Solo, which is designed for smaller sites with 16 channels or fewer that don't have a lot of need for expansion. And everything's on the back panel, all the I/O. So it's a single self-contained unit that you don't need to buy anything else to make it go. Arc Plus Touch is the flagship of the product line and the one that I'll spend more time on this evening. And as some of you are aware, the system uses a distributed I/O system so that you have these I/O units you can put around the facility close to the equipment that's being monitored and minimize wiring, that sort of thing. But it also allows you to put in some special function capabilities. The one at the bottom of the rack here is the AC8 AC controller unit as an example. Just above that is the Climate Guard or Plus XEM unit, which is, of course, our environmental monitor. So you can monitor lots of different environmental and security sorts of things. What's new here is our tri-temp sensor, which is a pre-wired sensor with 3 temp probes. So the idea is to put them at the bottom, middle, and top of the rack, so you can build a picture of the heat rise across the system and sometimes predict temperature issues based on what's, how that heat rise is distributed across the rack. But in addition to the sort of traditional wired I/O, obviously these days SNMP is very routine. When we first did it, it was kind of a new thing, but new for broadcast, I would say. It was quite old for networking at that time. But now lots and lots of pieces of gear have SNMP interfaces, and that makes it a lot easier to interface. So you don't have to run any special wires, just use the LAN connections to connect the SNMP stuff. And it doesn't have to be in the same building necessarily. It can reach across the WAN as well. And that's true of this whole architecture. It's possible to put the I/O devices at a distant location if that's your desire. So the idea is that everything at the transmitter site now, it's a combination of SNMP and hardwired connections. Everything can come back to the Arc Plus unit for control. And many of these pieces of gear also sit on the WAN, obviously, with their own web interfaces. And it's possible to reach into a lot of them individually. But of course, the Arc Plus has the benefit of giving you the whole picture of the site and highlighting issues and sending alarms, that sort of thing. So it's your one stop for the condition of the site. And I guess we're best known for transmitter remote control, but we do operate in studios, and a lot of that same gear and other pieces of gear in the studio can also be monitored and controlled. Studios, rack rooms, that sort of thing. And again, the picture shows a second Arc Plus Touch. We'd love people to put a different Arc Plus Touch in every room of the building if they wanted to, but you also could share Arc Plus Touches across studio and transmitter. Generally speaking, I talk a lot about the autonomy of the systems and the intelligence of the Arc Plus system. And that Arc Plus being in the studio, being physically in the transmitter site, means that you have some insurance that if you don't have communications to the site, things are still going to continue operating. So there's benefit to having the unit at the site. So it's a kind of a trade-off on how you set up your configuration. But in addition, or either at the studio or the transmitter, obviously, power systems is another area for monitoring and control. And then using the climate guard system, bringing in the temperature and security things. So really the idea is to bring everything you can into that architecture, that environment for management. The Arc Plus Touch itself has a variety of means for direct interface, customer interface. And the first obviously is the touch screen, which can be useful for direct control at the remote site. And the telephone, the RSI, the recordable speech interface is still on almost every system we sell. And there are, I think, several reasons why that continues to be a valuable asset even in today's world, because a lot of times those phone lines are actually VoIP. They're coming in over the IP circuit, but there are a lot of benefits. One of them, I think, is just the ease of connection. Sometimes we have kind of onerous IT policies that put, VPNs and logins and things like that between us and the remote site. And a phone call may just get right in there and get you to the action. Also on the receiving end of alarms, if you have those coming in to your personal phone, you can have your selective ringing set up so a red alarm from the transmitter site can wake you up with a loud alarm where everything else could be muted. So there's still a lot of interest in the RSI. And then what's showing here is that we do have alarms emanating from the Arc Plus directly in email and in addition to the phone, but in email and text form, which can hit your cell phone. And one of the interesting things about them is that they can include a link which can give you a quick access to bring up the mobile interface for the web interface. So this mobile interface is the direct web server that's coming from the Arc Plus Touch itself. So all these interfaces I've been talking about here are direct user interfaces. And then if you're coming in from a computer, you can hit the other version of the standard web interface. So everything this is actually a very good operating interface. I work remotely with units in the office frequently, and this is kind of a very common interface to get access to all the channels, all the meter status and command channels and the alarms, et cetera, macros, events. And one of the other things that's interesting about this interface is we have these channel banks. Do you see my cursor, or do you just, I have a little arrow I'm pointing with here.
Yeah, we see it hovering around all channels.
Yes, okay, good. So the all channel is just a channel bank selection. It's now been enhanced to 32 different channel banks. So the channel banks selection determines what channels are displayed on this screen. And we've enhanced this so that now the channel banks can be assigned to user logins. So depending on when you log into the system, you're shown a set of channel banks that are pre-assigned by your system administrator. And so in some cases, you may want to limit people to what they can control or monitor. So that's one of the newer capabilities. But now looking at what I like to refer to as the autonomous capabilities of the system, the smarts that sit at that remote site embedded in the remote control itself. And one of them is virtual channels, the ability to calculate compound values based on direct meter and status channels, but then using any combination of, mathematical or logical equations to calculate compound parameters. And then once those are calculated, they're updated dynamically so you can monitor them and alarm them just like a regular direct channel. So things like heat rise or efficiency. VSWR is another very common one. Total power. I'm seeing some interesting distortions of my screen. I wonder if that's a zoom effect, but no big deal. Another of these remote embedded capabilities in the remote control unit are jet active flowcharts, and these are we do have the ability to write macros using a regular line-by-line macro language, but it's, I think, preferred in most cases to just use the drag and drop flowchart editor, which makes it pretty easy to create a diagram of your logic and then you're done. You don't have to turn that into code. So these are just some examples, turning on a transmitter, switching transmitters. Let me catch up with my notes to make sure I'm not missing anything here. Oh yeah, and then these flowcharts can be triggered in a number of different ways. You can trigger them manually if it's just a sequence that you want to be able to initiate yourself, or they can be triggered based on alarm. They can be based on time of day. They can be based on your broadcast calendar. So it's pretty flexible mechanism to get things done. And I mentioned the broadcast calendar. So that's with the times from the station license, being able to trigger things at sunrise, sunset, that sort of thing. So you can just enter the data from the license and then set up events to be triggered. And again, like a stuck record, these are all things that are embedded in that remote control system. Another one that was added some time ago is remote captures. So again, we have centralized systems to do logging, but the captures are captured right on the unit itself. So again, if you're running and you lose communication to the site, the captures can keep capturing that data either on a timed interval or based on based on events. So that is another sort of resilient aspect of the system. And one of the more recent things, Rob is familiar with this capability, the timers. There are 64 timers in each system now, so that they can be used to count time or count events. So you could this is an example of calculating elapsed time since maintenance events is one thing to do. Runtime. So for example, dehydrator runtime, such as we have at the AU Tower, monitoring and controlling dehydrators. Or even tracking events. So how long has it been since something happened? How long did that event go on? That sort of thing. So if you can, and timers, like all these other bits and pieces, the timers and the virtual channels can be all pieces of jet active flowcharts. So you kind of put all these different elements together and it becomes kind of a programming environment that that can get pretty complicated. So this has all been talking pretty quickly, a brief run through of the basic capabilities of the Arc Plus Touch. So here's a pseudo remote site, and so the idea is that each of these remote sites, as I said, has some autonomy. And as we begin to control them from a central location, one of the concerns is always, what happens if we have a failure of a link to one of the sites? And that's where all this autonomous operation comes in that I've been describing. So if this happens, the captures keep going, the jet active flowcharts can react to what's happening when you're not there, that sort of thing, until you're able to restore a backup connection. The other interesting thing about this picture is it's really the first example in this presentation tonight of a network operations center. So over the last, 10 years, I guess, the whole topic of NOx has become much more important, much more interesting, and more common. And so this is an example, a pretty simple example of a NOC. You have a computer and each with a IP connection to each of the remote sites. And this is the NOC architecture that can be implemented with our autopilot program, which runs on a computer. And we have NOCs, very large NOCs, a few hundred sites running in this way. And if I take another look at, here's the sort of the dashboard for autopilot. And on the left, you have a lot of docking windows looking at sites and custom views. We'll talk about custom views some more. There's a navigator view down here that I can use to build trees of information, which we can look at a little bit more closely. Up here are the resources, the basic sites that are connected, and alarms at the bottom, events. So a whole range of information available. And this product, this program, Autopilot, is really two things. It's known by most of our users as kind of an engineering toolbox. So it's very common for an engineer to have this on his or her notebook computer and have connections pre-programmed to each of the sites he's involved with or responsible for, and can quickly connect. And this is this view in the middle is the default view, which is available without any, you don't have to do any graphical design. This is just a standard view of status, meter, and command channels. And the channel bank up here is just showing you 16 channels at a time. So there are up to 256 channels in the Arc Plus Touch. So this gives you banks of channels to view. But I mentioned custom views, and a big piece of this product is all about custom views. So there's this graphical engine in here that allows you to design your own graphics. So here's a hypothetical station, WDHH, and main and backup transmitters, AC monitoring, all the stuff you have, including bringing in video feeds from network cameras, that sort of thing. This pane down in the bottom left would be tied mostly to a climate guard, plus XEM unit, that sort of thing. So the flexibility of the custom view is really the thing that I think most people think of first. Certainly I do in terms of autopilot. And it's also the centerpiece of many NOCs. So this kind of a display is really well suited to put up on a big screen on the wall. And we're looking at one station here. Here's a Beasley station that we highlighted at an NAB show a few years ago. Looking at with detail at one station, and you can see the graphics allow each individual engineer to kind of express himself, let the artist come out. but it can also be a small group. This is a hypothetical example of a small group with 4 stations. Actually, two stations with main and aux. Or bigger groups. Are you seeing a black box at the top or that's blocking out part of the screen? Maybe it's just me. Anyway, this is the system that was put together in Panama, and of course it's a nationwide system, small nation, but it gives you the idea. So autopilot, and we do, as I said, have large autopilot systems implemented. This is a hypothetical one that shows how the navigator pane can be used. So the left, we have all these states identified in the navigator pane. So we create nodes for the states, and then within the nodes, I can open up here in Florida. I'm showing a few cities, and then within Jacksonville, a station. And the interesting thing that's happening here is these multiple status indicators that have been dragged onto the screen are connected in the background to the nodes in the navigator. So this Wyoming indicator is tied to whatever you've dragged into the Wyoming node over here. So it's saying there are 2 sites with 1 red alarm. There's 1 site with 2 red alarms, 1 site with 1 yellow alarm in Wyoming. The other states are all happy, that sort of thing. So there's a lot of flexibility how you want to represent things. And then there's the drill down capability. So this is an example that says Florida got red. The arrow suggests that I should click there and open up a map of Florida. And there, once I get there, I can see, well, it's Jacksonville that's got a problem. And these are hypothetical stations, but I can then drill down to a site view and look for the red issues and deal with them. And as I mentioned, the graphical engine is what gives these screens their pizzazz. And we always, when we make these views ourselves, we're always highlighting, maybe because I'm an old guy, but I like the angular meters. And we typically highlight those pretty prominently, but there's often, maybe forward and reflected power in an angular meter, and then use text meters for a lot of other supporting data, which can be depicted in a variety of ways. So there's a lot of graphical flexibility. So that's autopilot, and that was Burk's original and continues to be a major part of our remote control architecture. And as I mentioned, it serves 2 purposes, that it's still an important toolbox. Another thing that we found with NOCs is when you start building these big nationwide national NOCs, there's sort of 2 elements. There's the NOC people with their own view of what they want to see and do, and then there's the local engineering team with a different, typically more detailed view of what needs to happen. So it's very common that we'll have local engineers running their own autopilot systems, accessing the same sites that the national NOC is also accessing. So autopilot gives you that flexibility. But now we also have the new product called Arcadia. And Arcadia, you'll see, has brought in many of the elements of our autopilot. It can work in conjunction with autopilot. As I mentioned, if you have an Arcadia system in your network, your engineers can still use autopilot to access those same sites. So two are sort of critical differences with Arcadia. One is There's a whole new user interface that's tailored for mobile devices. It's a responsive interface that adapts to cell phones and tablets, but also can be viewed and used on a computer screen. So it's a web-based interface. And the whole intent is to get you easy access to all the sites that you're authorized to see in your organization, and to do that in a secure way. So when we looked at that initial NOC example with autopilot reaching out separately to several sites, or even 100 or 200 or 300 sites, you have an individual IP connection from that computer to each site. This is a different architecture that says there's a centralized server that reaches out to all your sites, and then you as a user just hit the server. You hit it from your cell phone, or you hit it from a NOC station. So that's the key thing. We consolidated access. The Arcadia system collects the most recent information from all those sites. It's always sitting there. And when you hit it, you get all the information about all the sites, but it's only a single connection. So when you have a lot of people on a lot of sites, there's just a huge efficiency in communications. The other thing is the communication from your mobile device or your NOC station in Arcadia go over TLS links, which are encrypted, the transport layer security. So they can travel over the public internet. And then there's the other aspect of this, which is user authentication. So in Arcadia, in particular in the mobile interface, right down to the channel level, you're authorized to see particular channels and particular sites. And that authorization is tied back to your user identity. And that user identity can be related to your Microsoft Active Directory system. So in a big organization that uses Active Directory, this can facilitate managing these permissions, and you can predefine profiles for different types of employees, that sort of thing. Some people don't have Active Directory or prefer not to connect the Arcadia system to the Active Directory. And then there's the standalone version, which is known as LDS, so Active Directory, right, what's LDS? I'm losing it at the moment. But it's a standalone system that runs on the server itself. So you can manage individual credentials for the Arcadia system as opposed to using the Microsoft Active Directory. You can actually do both. You can use the Active Directory and in addition set up an LDS system. And then, as I mentioned, the key with authorization is everyone who logs on has access only to specific sites and channels. And that's a common theme through this whole architecture. So network integration with Arcadia is an interesting topic because now we're dealing with many sites, we're dealing with different networking technologies, and in particular, different IT departments with different policies, procedures, regulations. So the network integration has to be flexible. Well, I've already mentioned that we consolidate communications. That's a key element of the network architecture. But also, we have to be flexible in our ability to adapt to these different IT policies at different companies and interact with and integrate with those IT systems. And then the final kind of interesting aspect of Arcadia is it's been designed to be served either from the cloud or from an on-premises computer. And I would say more of our customers run on their own computers. There's still a preference, I think, to control that computer, but we have many run in the cloud, some in their own cloud instance. So you go to AWS and get a cloud instance, it sort of becomes an extension of your company's networking environment. And then we can install Arcadia on that server. Or of course you can just put a server in your rack in the building. So looking first at the on-premises example, some of the things I've been talking about, here's the Arcadia server, presumably in this picture sitting in a rack in your rack room. This is showing that in that Windows Server environment, it doesn't have to strictly be Windows Server, but in the Windows environment, that ADLDS system is resident. In many cases, there is an Active Directory system being administered by the organization, in which case it can just piggyback on that as well for user authentication. And also we're showing that here, all these remote sites are kind of inside the firewall with presumably firewall protection and between each of the sites and the server. So again, there's one connection from the server to each of the sites, not a connection from each user to each site. And then here's the firewall, and out here the public internet. We're showing the transport layer security. The mobile interface can connect using TLS. It hits the server. Similarly, the NOC interface, and I'll talk about each of those a little bit further. So this is the key difference between this and the straight autopilot is the consolidation of communications into a single server. And that also, I don't have it shown here, but it is possible to have redundant servers. So there's different ways to do redundancy. We have some customers who actually have redundant NOCs. Some will have one part of the country in one NOC, the other part of the country in the other NOC, but the ability for the NOCs to cross over if needed, that sort of thing. So there's a lot of flexibility. Now, this next picture, it's all the same stuff, but just shifts the firewall. And now the AWS private cloud out in the cloud with the server there, coming in through the VPN to reach sites, to reach Active Directory, coming in through the firewall. There's also the ability with AWS to do VPN directly from the cloud to a site. So this opens up another avenue of communication. On the left here, the picture is still identical. The communication from either the mobile devices or the network operations center. And then another element that I didn't draw on here, but we do have customers who require their mobile users to have VPN access. So that's another layer of security that can be dropped on top of this. One of the interesting aspects of this whole architecture is it's all standard networking stuff. So as things evolve, they sort of naturally flow into the architecture as different generations of TLS and that sort of thing, different ways of managing VPNs, proxies, that sort of thing. So we have the ability to work with IT groups and fine tune the architecture to their needs. So we basically have now two different interfaces, two different ways of connecting into this from a user point of view. I'll talk first about the NOC. And gee, that looks familiar. That it says up here on the left, top left, it says Arcadia NOC instead of autopilot, but we all recognize it as the familiar autopilot dashboard. If you look closely, there are some differences. Or if you start working with it, one of the key differences is up here in the resources pane. When I say I'm an engineer and I have my own autopilot on my computer. The way I've set it up is I have access credentials on each of my 5 sites that I'm interested in, and I put those credentials into my copy of autopilot, and autopilot then reaches out and logs on to each remote system. Arcadia NOC is quite different in that regard. When I launch the Arcadia NOC program, I get a login screen and I select an Arcadia server and I log on to that server with my credentials. Then that server knows, based on my credentials, what sites I should have access to, and it automatically populates them up here. So now you have a situation where you could have this NOC environment with a large organization and several regional NOC operators, and each NOC operator might have a separate subset of stations that comes up when he or she logs in. Another major difference between Arcadia NOC and Autopilot is the way the custom views are handled. In Autopilot, as I mentioned, it's an engineering toolbox. People frequently go in, draw their own custom views to do exactly what they want to do. Arcadia NOC is based on the idea that it is a centrally administered network operations center. So the custom views are actually served from the Arcadia server. So the custom views that appear in the pane over here are the ones that are available from the server. So you could certainly imagine that a NOC operator by day who's calling in to run the NOC has this limited set of views and sites. He may also be a chief engineer and have his own autopilot that he's using to directly connect to several sites in a different way. So as I said, they're not mutually exclusive. But Arcadia NOC does have the advantage of this graphical engine, the alarm handling, et cetera, that we're familiar with from Autopilot. And so when we talk about NOC versus mobile, one of the things that differentiates it, I think, is this idea of being able to build a large screen display with lots of dense data for many, many sites. But another aspect, I have alarm management thrown in here. Alarm management is spread across the whole architecture, but I mentioned it here because obviously it's key in the NOC environment. Several items listed here: multi-level alarms, email, text, phone calls, alarm delays and rearm delays. Sometimes you don't want to have an alarm happen again until a certain amount of time has passed. Alarm actions and channel actions. We can take immediate action based on alarm happening or based on a channel changing value. And the first 4 of these items are in that autonomous category. They're resident on the system at the remote site. So those alarm actions and channel actions are happening immediately at the site. Similarly, the alarms emanate from the remote sites. So we're not putting an artificial element in the way of those alarms. They're going to go from the remote site right to your telephone or right to your computer in the form of email. But two at the bottom here are features of both Arcadia and Autopilot. One is alarm roll-ups, and this is the ability to sort of sidestep alarm storms by saying, if I have a major alarm, I've lost power, one of my power systems is down, I don't want to get 17 alarms that are caused by that alarm. So I can define relationships to prevent those alarm storms. This last one, alarm priority filter, is a particular interest in the NOC environment and something that we added as a result of working with companies building these NOCs, because I don't know of an example where customers had the luxury of saying, okay, we're going to turn up all these new stations with new remote control systems and put them in a NOC. In every case, we're collecting existing stations with existing ARC Plus systems, collecting them into a network operations center. So those have been constructed by different engineers, different philosophies, different priorities in terms of how things are alarmed and monitored. And so then the NOC operator is typically looking for kind of a subset of parameters, but with a similar treatment across all stations. So the alarm priority filter allows us to say, okay, these particular alarms from that remote control system will hit the NOC and others will be ignored. And typically the NOC, as I said, wants to see fewer alarms than the local engineering team. So that Arcadia NOC capability, and the other interesting thing that we found, I mentioned the term virtual NOCs. It was really, I think, during COVID that we started realizing that NOC isn't always a physical location, and that NOC operators were working from, their home offices, and it was more a matter of what information is available, what's shown on the screen, what kind of access do they have. So that Arcadia NOC brings that all the capability of a physical NOC into a sort of a virtual environment. But separate from that graphical representation and that sort of autopilot-oriented NOC view, we have the new interface, the mobile interface. And this was designed to work on, cell phones and tablets and be able to contract and expand to work on all the devices that we all use these days. And one of the things you'll notice is that there is a family resemblance between the Arcadia mobile interface and the familiar autopilot interface. We still have our angular meters that we love so much and strip charts. What's different, fundamental difference is in autopilot, those custom views are, you paint the picture exactly the way you want to see it. Things stay in the same positions all the time. With an Arcadia view, there's the ability for things to move around a little bit. So the rules are a little different because of the responsive nature of the interface. But you can, this is an example, Relevant Radio has been a major user of Arcadia, and this shows you can show a lot of sites. So it almost looks like a NOC interface, but it's on the mobile user interface. And then this other one, I love this example. GeoBroadcast is using, and this was again highlighted at NAB one year, using a web-based system. And it's an example where they don't have a physical location. They're a totally virtual organization, the GeoBroadcast guys. So they're, the physical locations they work with are their clients, in this case, Bonneville. But they're working their simulcast overlay and managing from, and their engineers are all virtual. So they use that aspect. The fact that it's cloud-based is great because they don't really have a place to put a server. They have no central facility. Very interesting virtual organization. I've got a few screenshots here just because the mobile interface or the browser-based interface is the newer one. I thought it might be interesting to look a little more closely at it. So this is where I'd log in. I just hit it with, in this case, arcadia.burk.com. If you went there, hopefully you wouldn't have login credentials, but you'd see this login screen. And the first thing I see is a series of tabs when I log in. So there's this one at the top that's called All Sites. And that's going to show me all the sites that I, as a user, have authorization to view. And then below that, there are, here they're called Northeast and Southwest. So this is in the middle, are tabs called Global Tabs. Global tabs are administered by your company's Arcadia administrator. So the idea with a global tab is I'm going to create a tree of sites based on, geographical organization or based on HR organization, however you need to organize your sites. And then that hierarchy of sites is available and visible to all users of the system. So all of your authorized users see the same tree of information, and then their particular access rights are overlaid on this tree, so that as I expand the layers going down the tree, I'll see only those sites that I'm authorized to. So it's kind of a combination of a fixed company view with an overlay of individual access credentials. So if I, for example, expand the All Sites tab at the top, this is showing me that I've logged in and I have access to these two hypothetical sites, and I'll expand WDHH. So what I'm seeing here is a default view. So this is very analogous to the default view that's visible in Autopilot. So there's no need to create this graphical view. It's created for you automatically by the system. And just as in Autopilot, it's showing you 16 channels at a time. And I can click next to see the next bank of channels. So again, that makes it easy. You don't have to do any special development of views. Going back here, though, if I now start opening up this tree, now, again, this is something that would have been created with your company, your organization in mind. So here's this Northeast view, and this tab in the middle called Summary is actually going to open up a matrix view. So the matrix view is what we call the graphical displays that we create. And this is just showing that a matrix view can incorporate data from any group of sites that are within this tab, so to speak. So this is saying here's, 32 sites, 16 sites or something like that, 20 sites, just looking at PPM as an example. I sometimes have heard that PPM is more important than being on the air, so that we chose that one in this example. Closing that summary, though, I want to open Boston. Now I've got some matrix views for the hypothetical WDHH. And so this, again, shows you the pretty strong family resemblance between an Arcadia view and the custom view, the matrix view and custom view. Angular meters, strip charts. This is a row of LED indicators for status. And then just as in Autopilot, we have the ability to do text meters. So this sort of dense collection of information on this row. Dehydrator minutes over here. So this is actually showing a timer value as opposed to a meter value. And then we have a set of raise lower pairs, so command buttons. So this is a clear alarm button. And then we also have the ability, if you want to link to existing websites. So I could click on this Burk button and bring up the Burk website if I wanted to. And then down here, we're showing that you can also do these embedded inline websites. So these are actually, if I were live, I could actually interact with this traffic site or this weather site. So you can embed websites inside your view as well. So very flexible graphical engine, but designed for the mobile devices. And going back up to the top now, another thing that's always of interest is how alarms appear. If I have an alarm that's happening somewhere in that northeast region, I can see here I've got two alarms in the northeast. And there's the three dots here. I can expand that, and actually, based on the tab, I get a roll-up of alarms and alarm history of everything within that tab. And closing that again, I can now open the tab for Northeast, and I can open that summary screen we looked at before, and lo and behold, our old DHH is having a problem. It's gone red on us. And then looking in Boston and open up the DHH view, and we can see that we're off the air and we have no RF. So it's very analogous. It has a drill down concept, but graphically distinct because of the way the interface is created. And one more thing at the top here, I mentioned the third category of tab is the user tab. So just as in Autopilot, an engineer can create his or her own custom views. In Arcadia, you can create your own matrix views. You can also grab a matrix view from the company's global tab and copy it down into your own tab and then make modifications. So it's very flexible. There's a edit mode you go into, and I won't show a lot of detail, but I can say I want to edit this test view, and then I can drag and drop elements, basically create the view that I want. So the whole thing is flexible. It's a toolbox in this sense, or you can rely entirely on what the administrator has created. So you don't have to do a lot of work. Your individual engineers can focus on engineering as opposed to design of views. So once again, that was a very quick pass through the system. There's this protocol we call Warp Engine. It's a UDP protocol, and it's central to both Autopilot and Arcadia. So it's possible to connect either TCP or UDP, but UDP has a lot of benefits. These very small packets. Once the control system learns the site, you don't have to retransmit all that redundant stuff like channel names and things like that. Just the data itself gets sent typically like once per second. And it's been updated recently. All 256 status channels go on every polling cycle. And then you can identify 16 high priority meter channels that also come on every polling cycle. And then the rest get spread over a handful of cycles. So UDP is part of the effort to, I should say Warp Engine is part of the effort to make the whole system update quickly and minimize communications bandwidth. So that was a lightning speed trip through our remote control and NOC architecture. What I wanted to do quickly now is jump back to the picture you recall where we had the Arc Plus with the stack of +X devices, some of them specific IO units, some of them special function. Well, this is a very special function +X device. Rob is very familiar with this one, the +X VSWR. So this device handles, can interface with up to 8 of these precision RF sensors, giving you 4 sets of forward and reflected power. And then it will dynamically calculate VSWR, and then it will do a fast trigger on a VSWR spike event or reflected power, depending on your philosophy. And then it'll work with a 3-strike system. So if you've had some kind of a transient it'll take you off the air, but then bring you back. And it'll do that up to 3 times. It's all programmable based on your company philosophies, but I think in most cases, after either 2 or 3 triggers, it's programmed to wait for human intervention. So the idea is, if there was some kind of a transient event, non-critical, damaging, they'll get back on the air quickly. If there's truly a failure, something really bad's happening out there, then it'll stay off the air and hopefully get the power off quickly enough to protect the system. And so plus X VSWR and PRF1 are available. That it'll run by itself. It's more typically part of either an an Arc Plus system, or it is the building block for the Arcturus system. So Arcturus is Burk's system for managing multiplexed antenna systems and often multi-tenant systems. And make sure I refer to my notes and don't miss any of the key elements here. But basically monitoring forward and reflected power on all the inputs and outputs at the combiner, making that fast decision based on either VSWR or reflected power fault, but also measuring and monitoring temperature and pressure and other key attributes of that RF system. And this is an example of a summary screen. And then being able to control, of course, it's happening. Some of this is happening automatically, but then you always have the manual intervention ability. And I think these screens are familiar to some of you. So the users can get in who have access to the screen. And it may just be physical access if we don't have remote access authorized. And so you can see also the dehydrator control up here. And obviously this example I'm showing is the AU tower system. And in a complex system like this, the Arcadia is, the Arcturus, I'm getting stumbling on our own acronyms, our own names, but Arcturus is doing a lot of stuff. I mean, it's doing the basic measurements we talked about, and in the AU case, we are controlling and monitoring dehydrators, doing temperature, humidity, but also some very complex jet active flow charts, operating the sequence of events, monitoring the positions of the jumpers and switches, and making sure that things are not happening at the wrong time in the wrong place. And also, in this case, implementing parallel redundant interlock loops. So we don't have the ability to take something off the air because of a failure or of a single interlock loop. So a lot of thought went into this, obviously near and dear to Rob's heart, and a lot of specific design work went into this. Some cool pictures of the facility. And here's Rob and Andy standing next to the Arcturus rack. So this is a very cool example of the Arcturus system and its abilities. And then one final note to kind of tie this back to all the discussion earlier. If you are running autopilot, if you are running Arcadia, then the Arcturus data can be incorporated just like any other site. So it all does tie together. And of course, autopilot itself is a key element of the Arcturus system. So wrapping up, just one final topic is this fairly new product we offer called Arc Now, which is engineering services. So one of the things that we've noticed over the years is, there is a lot of complexity in this system, and frankly, sometimes people don't have the time to really dig in and get as much out of it as is available. So we've created this service where we'll actually, take notes on your system and your requirements, and then pre-program the device, create custom views, make sort of a turnkey solution. And it's turned out to be a fairly popular offering. So typically the channels are pre-provisioned, and you're just instructed which connectors to hook up to on the I/O device. Flowcharts are written as appropriate. Alarms are configured. Reports and some specific custom views for your sites are created. So our guys can do these, more quickly and efficiently, and this allows you to leverage that ability. So that was my quick run through of Burk's current products and architecture. And so if there are questions, I'll attempt to answer them, or I'll be happy to take them back to the technical experts at the shop if you stump me. I'll get back to you guys.
Yeah, hi, Ed Schwartz here. Where's the camera? There we go. Quickie question on the data, the metering data that you're capturing and logging. Is there an ability to export it if there's something I'm logging that I want to do some trending on, and I want to, analyze or look at that data, outside of the control system? Can that data be exported?
Yes, so you can do a couple different things. One is if you're just using Autopilot by itself, its internal database is an SQL-Lite database. So it's that standard database format. So in itself, the first thing you can do is run reports, and you could extract information that way, or you could access the SQL-Lite file directly and do a query. The risk there is SQL-Lite is a single user. It's different from regular SQL because it's single user. So you'd have to either be working on an archive file or sort of stop the Autopilot program and access the database. A more flexible approach, you can also use an external SQL database. So in addition to the SQL-Lite database, it can continually log to an external SQL database, and that one is, multi application available. So you could run queries on that directly, even as the system is running. And this whole idea of looking at the data in the database, and it's frankly, very interesting, because there's so much good stuff in there to look at, and these days more interesting tools becoming available to do that. So
Chuck, one of the things that you talked about was the fact that so many devices are now SNMP, and you could have them report to a Burk or an Autopilot system, etc. Is there any way for the Burks to report upstream to some sort of larger facilities management system?
There have been examples of that, and that's something we can talk about. There are some capabilities there. So yes, give me a call. They're not front and center, but we do have some abilities to go upstream as well.
Yeah, because for devices that already speak SNMP, I could have them, talking to my Burk as well as talking to my larger system. but then I'm setting up both systems to interrogate the device. And then there are things that are just on my Burk, like metering channels and status channels, that ideally I would want those values also to be reported upstream.
Yes, yeah. And we can do that. That's something that on an individual basis we can work on how to enable that kind of capability. See, it's not out of the box, but it's a capability we can enable for you.
Great. Thank you very much.
Sure.
Yeah, I think, Chuck, I was thinking, but I think you answered it near the end that, I've toured a couple of sites. The one I'm thinking of is 4 Times Square in New York, where it's a combined antenna system, and one of the functions that they've implemented, and I'm sure when they built it, it was much harder to do, is something that basically turns a light on at the door to accessing the roof that basically says, well, if you go through this door, you will be exposed to more RF than you're supposed to. And so it mathematically, knowing the position of all the antennas and the power levels that are on the antennas, can compute whether that light should be on or not. And I guess the trick would be having a closure or something that would report both to turn the light bulb on and probably to all the stations that says, okay, the roof is now off limits. And it sounds like that's something that the I guess it was the Arcturus system that was multi-station idea.
Yeah, it could be in the Arcturus system. It could be as just a straight Arc Plus system because the virtual channel capability, depending on how you're capturing the basic information. So if you're doing a lot of direct measurement of forward and reflected power, then that does sound more like Arcturus or something with the plus XVSWR devices and the power meters. But, once you have that information, even the knowledge that the transmitter has been turned on, even if you're not measuring the power, that knowledge could drive a virtual channel that could ultimately, be a contact closure output from the system to turn the light on. I can't be sure, but I almost think that we have examples of that kind of thing.
Because in this case, it's because of the nature of that particular site that I'm sure there are others. No individual station actually controls that combiner. It's a somebody who knows the site better than I do would have to say how they. I don't know if it was. I think there's a organization that maintains and controls the combiner, but it was paid for by all the stations, but none of them actually control it.
Yes, and that's a very common. We see that in users of Arcturus. So in that sense, it does sound like an Arcturus kind of a operation where you have the Arcturus system monitoring the combiner and the antennas, but it's not that Arcturus system is not the property of any one of the stations. They each have their own separate environments for their transmitter remote controls. But the Arcturus system would be in a position to know all that information about what's ending up on the antenna.
Yeah, because I know that, they must detect the position of like all the RF switches. Because I know that the trick with the roof of that building, or one of the tricks of it, is if they happen to be using the aux antenna, which is lower on the mast, you can very quickly get to the point that nobody's allowed to go out there.
Yeah.
If they're operating under normal conditions where they're using the upper antenna, there are certain areas of the roof that are limited, but there are many others that are not because you're far enough away. So
Right.
that would be controlled by the property owner essentially. And I assume if the stations happen to have Burk systems, they could access the same data. And if they didn't, you could still provide them with a safe or unsafe condition that's not tied to their remote control in any way, but would, just tell them, well, in the mode that the antenna systems is running right now, you can't go out there. If
Right.
if you had a Burk system, you could tell, oh, well, there's this many stations plugged into that antenna, and you would know more. But you could give a go, no go, even if they were not a Burk installation.
Yes. Yeah, absolutely.
I don't know if they've done that, but it seems like, this has gotten easier with all the implementation that you've been able to do.
Yeah, it's certainly in the realm of doable kind of thing with all the capabilities, and it's just a matter of, as you said, the will and the focus and the interest to make it happen. But that multi-tenant multiplexed antenna sites is one of the realities of our tourist life. That's a very good question. Any other thoughts or observations? Or
Yeah, well, one other question. Of course, in the old days of remote controls, you bought a box that had a bunch of connections on the back and some software inside of it. How is a one of these remote control systems sold these days? Is it hardware plus software and software maintenance fees, or how do they sell them these days?
well, it's kind of all of the above. So the basic units are hardware. I mean, they're obviously running software inside, but an Arc Plus Touch is sold as a piece of hardware. We generally post firmware updates on the website so our customers can download when we don't charge for those firmware updates. And those Plus X devices similarly are hardware with the software firmware buried inside. So that's very traditional sort of capital equipment expense oriented. When we get into autopilot also is based on a sold license, and the autopilot is licensed per managed system. So you buy you say, I have 10 sites out there with Arc Plus systems in it. I put an autopilot license in each Arc Plus system. The autopilot program itself, you can download free off our website, but it doesn't do a lot for you unless you have some licensed units to control it with it. So that's a fixed cost per unit. So it's kind of like a capital equipment cost. It's not a recurring cost. When we get into Arcadia, there's a couple different approaches, but it is server-based, and we do have a maintenance fee that applies to the server software itself. So that's where we begin to get into a recurring cost model. So it's kind of evolved in that way. And I certainly appreciate having the opportunity to talk with you today. And please do reach out to myself or to Matt Leland or whoever your Burk contact is, and we'd be happy to talk with you.
Chuck, I really appreciate you making time to do the presentation for the chapter.
Great. Well, I enjoyed being here and look forward to talking to you guys again in the future.